Okay, let's talk about the mean value theorem. The mean value theorem says that if f is a differentiable function on the closed interval ab, then there exists a number c between a and b such that the derivative of f evaluated at c is equal to f of b minus f over f of a divided by b minus a. So let's try to understand this in a biological context for the growth of fish. And we're going to return to an example we saw in a previous video where we're looking at the length of rockfish at age A, and we're calling the length L. And the length L is given by a cubic polynomial, which is shown right here. And in fact, if you graph out the function L, it looks something like this. Here, the horizontal axis is A, and the vertical axis is L. Now, consider the following. Suppose a fish lives to the ripe age of 14 years. Calculate the average growth rate over 14 years. And then we can ask, at what ages is the instantaneous growth rate equal to the average growth rate? And you may recall that the instantaneous growth rate of a fish of age A is given by L prime of A. Okay, so let's start with the average growth rate between age 0 and 14. That would be L at 14 minus L at 0 divided by 14 minus 0. And if we plug this into the calculator, this is about 26.13 minus 1.21 divided by 14, which is approximately equal to 1.78 inches per year. And so that's the average rate at which the fish is growing over its entire life, approximately 2 inches a year, just under. Now we're interested in when the instantaneous growth rate equals the average growth rate. And so to calculate the instantaneous growth rate, we need the derivative of L. Now L is a cubic, and so we can differentiate it term by term. And so L prime of A is equal to 0.0155 times 3a squared minus 0.372 times 2 times a plus 3.95. And if we work out each of the terms, this comes out to 0.40465 a squared minus 0.744 a plus 3.95. And so we're going to try to answer this question. And so we need some value of A such that L prime of A is equal to 1.78. Now, if we look at the mean value theorem, we know that there must be at least one age such that the instantaneous growth rate equals the average growth rate. Why? Well, if we choose B is equal to 14 and A is equal to 0, then you can see that we're asking whether we can find a value. L prime of A is F. Well, we're calling the function L here instead of F, but it's still a function. Okay, so it's L of 14 minus L of 0 over 14. And we want to solve that equation. So by the mean value theorem, we know that there must be a number that satisfies this, that lies between 0 and 14, because the cubic polynomial is a differentiable function. Okay, so let's go ahead and calculate the value or values of A that satisfy this equation here. And recall that this value is 1.78. And so what we need to do here is look at the polynomial here, put it on the left-hand side. So we have 0.08 0.7465 a squared minus 0.744 a plus 3.95 is equal to 1.78. Okay, so we can then subtract 1.78 from both sides to get 0.0465 a squared minus 0.744 a plus 2.17 is equal to 0. This is a quadratic here, and so we can use the quadratic formula, polynomial of degree 2. And if you haven't used the polynomial formula for solving a quadratic for a little while and you feel a little rusty, look it up again. So the quadratic formula gives a is equal to 0.744 plus or minus the square root of 0.744 squared minus 4 times 0.0465 times 2.17, okay, divided by 2 times 0.0465. Okay, so if we put this on the calculator, this gives a is equal to 3.837 and a is equal to 12.163, and these are both years. Okay, so what this is saying is that at just under 4 years and just over 12 years, the instantaneous growth rate for the fish is equal to the average growth rate over its entire life. Okay, so we can understand this now in terms of this diagram. This has got a slope here of 1.78 because it's the rise, L of 14 minus L of 0 divided by 14. So this has got the slope of 1.78. And then we ask at what ages does this curve have a slope of a tangent line equal to 1.78? And we find there's a point about right here where the tangent line is parallel to the other line. And there's also a point about right here. And so this point here is 3.837. And this point here is 12.163. And so you can see there's 2 times in the fish's life where the instantaneous growth rate is the same as the average growth rate. And to understand why this would be true, the fish starts off growing quite quickly. We see the slope of the line is quite large initially. And then when it gets to middle age, it kind of slows down a little bit. Okay, so now L isn't increasing as much. But interestingly, when it gets a little bit older, the growth rate speeds up again. And so there's 2 times when we see this transition from fast to slow and from slow to fast growth rates, where the growth rates are equal to the average growth rates. And so this is kind of a physical interpretation of the mean value theorem for the case of the growth of fish.